hopefully you've done the Unit 5 review already and you're just coming to check your answers. If you have any further questions after viewing this, please come in. I'm here in the morning or I'm after school for probably about a half hour to an hour each day. All right, let's get started. So on 5a, we need to calculate the discriminant. The discriminant is b squared minus 4 times a times c. In order to use the discriminant, or use this, you need it into the quadratic equation set equal to 0. So that's where the ax squared plus bx plus c equals 0. We need the equation equal to 0. So in the first problem, we need to subtract 9. So we have negative 7b squared minus 9b and the minus 9. Not like terms, so they can't go together. Now we have the a, b, and c. A is always with the variable squared. B is always with just the variable, and C does not have a variable on it. Let's put these into b squared minus 4ac. So negative 9 squared minus 4 times a times c. Put this into the calculator exactly how you see it. So here it is on the calculator. We hit enter. We get negative 171. You get a negative, that means there's going to be two complex solutions. You could also use imaginary, but I'd really like to use complex. So two complex solutions. Number 2, set it equal to 0. Easiest thing to do would be add n squared. Really does not matter. 0 equals n squared. And I'm going to put from biggest exponent to smallest. Positive 1, so plus 1. So we have a equals 1. There's a 1 in front of the n squared. B equals negative 2, and c equals 1. So we have b squared minus 4 times a times c. Now put this into the calculator. Like so, put it in the calculator, hit enter. Always make sure to have parentheses around that a, or the b squared. This equals 0. Anytime you get 0, that means we have one real solution. So there's only one solution to this problem. And it's the answer I'm looking for. Moving on. Set equal to 0, so add 3a. Add 3a. Get 9a squared minus 1. They actually end up canceling out. So that means we don't have a b, no b. So that would be, if there's no b, that's like 0. 0b. So our a is 9, b is 0. When you say there's not there, it's there. There's a, b, c are always numbers, and they're always there. So in this case, we got a, b, and c. B is 0. So we have 0 squared minus 4 times a times c. Again, let's put this into the calculator. So it's in the calculator. I do value that you do this in your head, but I always would check it in the calculator. So put it in the calculator, we get positive 36. If we did this in our head, we have 0 minus negative 36 on the right side, and that'd be plus, so that equals 36. Positive number, that means there are two real solutions for this quadratic. That is the answer we're looking for. Number 4, again, let's set it equal to 0. Does not matter which side you have equal to 0. Negative 8x squared, that's 6 also. Minus 9x minus 10 equals 0. So our a, b, and c, our b is negative 9, our a is negative 8, and our c is negative 10. Put this straight into the calculator. So put it in the calculator, hit enter. Oh wow, big number. Oh, I entered it in wrong. I had a square in there. Extra square, I don't need that. That would be why it's such a big number. That's probably better. Negative 239. Negative number, two imaginary, or even better yet, two complex solutions. I will accept imaginary, but I'd rather have you write complex. Moving on. So now we need to solve using the appropriate strategy. Well, the appropriate strategy is using the quadratic formula. That is the appropriate strategy we're going to use. So first thing you need to do is set the equation equal to 0. I always like my a to be in positive, so I will move these other equations to the other side of the equal sign. So it's 10b squared, so the a is positive, plus 6b plus 1 equals 0. You technically don't need a positive, but I prefer it. So we have the opposite of b, plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. So simplifying this down, underneath the radical, I will put that straight into the calculator. So I have it in the calculator, that the discriminant, hit enter, I get negative 4. So square root of negative 4 all over 20. Now let's simplify the radical. So simplifying the radical. So square root of negative 4, in this case that one's pretty easy. Square root of negative 4 is 2i over 20. Square root of 4 is 2, the square root of negative 1 is I. So now we have, anytime you have those three, the number in front of the plus minus, the coefficient, in this case 2, and the denominator all have something in common, you can simplify it. So all three of those numbers are all divisible by 2. So divided by 2, divided by 2, divided by 2. So we have x equals negative 3 plus or minus 1 times I is I over 10. I can't go any further because it's imaginary. So you can't simplify it down any further than that. All right, moving on. Next one. We have it set equal to 0. 5a squared plus 10a plus 1 equals 0. So we have x equals the opposite of b, plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. Okay, let's put the discriminant, what's underneath the radical, let's put that into the calculator. I'm going to put it in the discriminant into the calculator, hit enter, we get 80. So let's replace what's underneath radical with 80. 2 times 5 is 10. Now I have to simplify 80. Let's do, or square root of 80. So we're breaking it down with the trees to simplify. Choose prime, choose prime, 2 and 5. So we have a couple pairs here. We have a pair of 2's and another pair of 2's. So the next step is x equals negative 10. 2 times 2 from the pairs is 4. Square root of 5 is positive, so there's no i's. Over 10. Just like the last problem, we have those three numbers. If they have something in common, we can simplify it. So we have x equals, divide all by 2, negative 5, plus or minus 4 divided by 2 is 2, 2 square root of 5, and the denominator divided by 2, you get 5. And there's your final answer. Moving on. Let's set it equal to 0. Our A is 4. B, there isn't a B, so it's 0. And C, the number that's always by itself, no variable, is always your C. So now we have x equals the opposite of b. That doesn't really make a whole lot of sense, but opposite of 0, 0 squared minus 4 times a times c, all over 2 times a. Keep simplifying this. X equals the opposite of 0 is 0. You don't really, 0 plus something or 0 minus something doesn't do it, so let's drop the 0. Underneath the radical, put that into the calculator like every other problem. Hit enter. 1,936. That's an ugly number, but it must be right. 1,936. Some number, big number like that, I would probably check it in the calculator to see if it's perfect square. Oh, just so happens it is. So I'd always check a big number to see if it's perfect square. So it is 44. So you have x equals positive negative 44 over 8. We can actually simplify this, break this up into two problems. We have positive 44 divided by 8, which is simplifying, you get 22 over 4 if you divide by 2. Divide that by 2, divide that by 2. So we divide it again by 2, we get 11 over 2. 11 halves, or 5.5 is one of your answers. And you get a negative 44 over 8, which is the same thing, just with a negative. So that simplifies down to negative 11. That's a 2. Negative 11 halves or negative 5.5. And our last problem in this section, so we set it equal to 0, 3b squared minus 4b plus 6 equals 0. Opposite of b, so now it's positive 4 plus or minus b squared, put it in parentheses, minus 4 times a times c, all over 2 times a. Let's put it underneath the radical, let's put that into the calculator. Put discriminant in the calculator, hit enter, you get negative 56. Alright, so we have 4 plus or minus negative 56 over 6. Break the 56 down. 28 and 2. 2 and 14. 2 and 7. Okay. So we have a pair of 2s. Doesn't matter which pair you have. So x equals 4 plus or minus 2 on the pair. The negative comes out as I. Don't forget that I. And underneath the radical, you still have the 7 and the 2. 7 times 2 is 14 over 6. Simplify this. You have, that's an ugly looking heart, but 4, 2, and 6 are all divisible by 2. So divide by 2, divide by 2, and divide by 2. So you have x equals 2 plus or minus 1 times I is I, square root of 14 over 3. That's a 14, square root of 14. Moving on. For number 9, we just need to predict this, so let's put it, we have one of the equations already drawn out, the quadratic on the graph on the right. We need to put this into the calculator. So I have it in the calculator. The reason why I want to do this is I want to get some points. So I can graph that linear equation onto put it on the graph. So negative 4, 5, negative 3, 2, negative 2, negative 1, negative 4, 5, negative 3, 2, and negative 2, negative 1. Graphing this. Now this is kind of tricky. How many solutions do you see here? Well, you only see one. But you need to think, eventually this is going to keep going up. And is going to keep going through. So there's going to be two solutions. So predict the number of solutions. 2. And this number 10, just put this into the calculator. So I placed both into y equals both equations. Hit graph. How many times do these intersect? None. Never. Never will, so that would be a no solution. Moving on. D. Here we have to actually solve. So here we're actually for 5D and 5E you solve. So for 5D we need to set each equation equal to 0. So I'm going to take the top equation and set it equal to 0. So easiest way I think is just to move the negative 2y over. Then divide by 2. Divide everything by 2. So y equals, and in the calculator, you have to put parentheses around the numerator. And so that will enter that in. And this other one, if I add y to this side, and I add 2 to the other side, that will get us x plus 2 equals y. So our other equation is x plus 2 equals y. So let's put this into the calculator. Okay, add it in the calculator, both of them. Hit graph. And it looks as though they're going to cross twice, intersect twice. So let's see if they really do. So you go to second, trace. We're looking for the intersections. First curve, just hit enter. Second curve, hit enter. For guess, I think there's 2 intersection points, so what I do is I go to one side where I think an intersection is, I move the tracer, move it to the right, hit enter. And we get 1, 3. If I do that same process over, so intersect, first curve enter, second curve enter. Now with guess, I'm going to go where I think there's another intersection. So I'm going to go to the totally opposite side of the intersections and hit enter. So I had 1, 3 and negative 1, 1. There are my 2 solutions. There are both my solutions. For number 12, pretty easy. That's a whole question. We have 5, 3 is one of your solutions, and 0, negative 2. And those are your solutions for when you have 2 equations on the same graph. Okay, number 13 is going to be very, very similar to number... It's going to be very, very similar to number 11. So we have to set equal to y. Easiest thing to do, just add every term to the other side to get the y by itself. So I have to add 2x squared, so 2x squared, subtract 10x, and add 4. That's the top equation. The bottom one, again, since the y is equal or positive, I would move every term over. So that y equals, so when you move 11x squared to the right side, it's going to be minus 11x squared plus 68x minus 113. Now let's put this into the calculator. So I put them into y equals. Let's graph them. So I don't really know what's going on at the bottom of the picture, so what I'm going to do is I'm going to try to zoom out. So I go to zoom out, hit enter. I want to zoom out. I'm going to move the tracer closer to the intersect, or where I want to zoom out at. Maybe I should zoom in. I don't know, let's try to zoom out first. Alright, probably should have zoomed in. Let's zoom in. And let me zoom in again. That's an ugly one. Alright, zoomed in, and I only see one intersection. If you don't zoom in, so if we do zoom 6, if you don't zoom in to tell if there's 1 or 2 intersections, we're going to do the second trace, intersect number 5, first curve enter, second curve enter, guess, move the intersection closer to, it's tough to see, but right now it's, you can see the tracer, it's close to the intersection, enter. So this is 3, and then sometimes the calculator comes up with crazy decimals, but that's really, really close to 3, and it's really, really close to -8. So 3, -8. If I do this again, go down to intersect number 5, first curve enter, second curve enter. I want to move the tracer a little bit over to the right. And this will tell me, if I hit enter here, I'm on the other side of the intersection. It tells me a different number, then I know there's more than one intersection. So 3, that again is really, really close. 2.99999, that's 3. And -8.000001, that's -8. So 3, -8. That is our one intersection here. Over on number 14, you have 1, 2, and 3, 2. Those are my 2 points, 2 intersections. That will conclude your review. Please come to me with any questions you have. I'm here in the morning in math planning, after school. I'm in 2519, or in math planning. Okay. Good luck.